Hello, this is Taiki again, and I'm going to present a problem from the team round this time. So, team number 9 is given a circle with center O, points A and B lie outside of the circle such that AB is tangent to the circle. The angle bisector of angle AOB intersects AB at P. Given that AO equals 16, BO equals 8, and OP equals 8, what is the square of the radius of the circle? So for this problem, we're going to first, of course, draw a diagram. So we have a circle, and it has center O, and then we're going to draw segment AB. So it's going to look something like this. And then we have the angle bisector of AOB. First, we're going to label AB, and now we have angle bisector, and it intersects AB at point P here. And now we're ready to do some observations. So first we see that BO equals 8, OP also equals 8, so BOP is isosceles. And then we have the angle, this is an angle bisector, OP. So with AO equaling 16, we can also use the angle bisector theorem. So that says that the ratio AO to BO is equal to the ratio AP to BP. So if we let BP to equal x, then AP would equal 2x. But to make things easier, we're going to call these, instead of x and 2x, we're going to say 2x and 4x. And the reason why I'm doing this is because now we can draw this radius connecting O to AB. And because AB is tangent to the circle, this is actually a right angle. And furthermore, because BOP is isosceles, that means that if we call this foot x, then xp equals xb. So we can replace this 2x with simply 1x and 1x. Now, this diagram is not to scale, but geometrically, this is what is actually happening. So then we can use the Pythagorean theorem on AXO and BXO. So we have OX squared plus AX squared equals 16 squared, or AO squared. And then we have OX squared plus BX squared equals BO squared, which is 8 squared. Then we can set things equal, so we can subtract AX from both sides, and we can subtract BX from both sides, and we can set these two expressions equal. So we have 16 squared minus AX squared equals 8 squared minus BX squared. But realize that AX squared, well, we labeled it as 4x plus x. So this is going to be 5x squared. And similarly for bx squared, we have bx equals x. So bx squared is x squared. And then this 5x squared becomes 25x squared. So now what we can do is move the x's to the same side and move the non-x's to the same side and combine like terms. So adding 25x, we get 24x squared. And well, 16 squared is just 4 times 8 squared. So subtracting an 8 squared, we get 3 times 8 squared equals 24x squared. 24 is just 3 times 8, so we can divide by 24 on both sides to get 8 equals x squared. So finally, we want to find OX, because OX, as we said, was the radius of the circle. So OX squared equals 8 squared minus bx squared, so 8 squared minus x squared. But we know that now that x squared equals 8, so we just have to do 8 squared minus 8, which equals 56. And that's our answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.